Welcome, everybody, to my talk today on a practical CI/CD framework for machine learning at massive scale. My name is Alejandro, and a little bit about myself. I am engineering director at Seldon Technologies, an open source company focused on productionization of machine learning models. I'm also the chief scientist at the Institute for Ethical AI, which is a UK-based research center that focuses on the development of responsible frameworks for machine learning, the operation, deployment, and also I am the ACM Council member at large, where we focus primarily in my contribution with the European Technology Policy Committee, as well as other committees. But today, yeah, we're going to be delving into why production machine learning is so hard. And also how to provide a solution that scales across thousands of models. So as you know, when it comes to machine learning, there is a broad set of challenges that we face. This includes specialized hardware, complex computational graphs, compliance requirements of the assets that are deployed, as well as the reproducibility of components. And if you're interested in the space, I have previous content that you can check out as well. But also today, what we're going to be asking is, how do you not only address production machine learning, but how do you deal with thousands of models across various environments with different versions of models that are being deployed? So some of the challenges that you face at scale includes things like complex accountability structures of who should be providing sign of where, advanced observability and monitoring challenges when it comes to complex specific machine learning use cases, governance and policies that need to be enforced, not only once, but also throughout the life cycle of models, the shifting capabilities, the shifting requirements on privacy as technology evolves, data sets can provide new insights, and hence risk can be introduced. Explainability, compliance, and other things like adversarial security, privacy-preserving machine learning between others. And when it comes to this perspective, there is also the end-to-end approach. So it's not only about tackling it from a bottom-up approach, but also ensuring that the principles and guidelines that are on the overarching perspective have the underlying industry standards and regulatory frameworks. And then from that perspective, you have the right tools and frameworks and platforms that allow you to really address that end-to-end, because ultimately, we can have multiple discussions on how principles around algorithmic bias are important, but if you don't have the underlying infrastructure to enforce them or to ensure that they're being tracked, then there's no point on those higher level discussions. So for that perspective, at the Institute, we came up with a set of principles for specifically practitioners of AI, not just technologists, but broader teams, things that you may find quite reasonable, like human augmentation, bias evaluation, et cetera, which we have provided for some practitioners to adopt, right? But as we mentioned, principles are not enough, right? It's necessary to go level deeper. And for this perspective, there is a set of initiatives that are aiming to tackle this challenge of what is now referred to as the concept of MLOps. And what MLOps is defined as is as the extension of DevOps to machine learning as a first-class citizen. And more specifically is the infrastructure and tooling that is used to productionize machine learning and then scale this production machine learning capabilities. And there are several working groups that are currently exploring this further. One of them is the SIG-MLOps committee, which, as many other open source working groups, it is led for practitioners by practitioners. And as you can see, MLOps in itself is the best practice across multiple disciplines that are not just from the technical aspect, but have to go beyond the algorithms, ensuring that they engage a broad range of other policy experts or domain experts, which are still necessary for this. And the key requirements to address here, it's going to be the principles of orchestration How do you orchestrate thousands of heterogeneous models? Advanced ML insights. How do you ensure that models are being monitored, not just through the usual metrics, but also through advanced metrics like explainability, outlier detection, concept drift, etc. And then lineage. How do you make sure that throughout the end-to-end life cycle of a machine learning model, from the time that the data is trained, the data is cleaned, processed, the model is trained, the model is deployed, the model is promoted. How do you ensure that there's lineage and auditability across all of these different phases of your machine learning? And specifically, the first question, from these 3 principles that we're going to be addressing is, how do you go from model artifacts or model code into fully fledged deployable microservice that is providing logs, tracing, metrics, etc. And for starters, we're going to be using this library called Seldon Core. So Seldon Core, it allows you to go, as already alluded to, from Python code or Java code or R code into a fully fledged microservice, right? And the way that this is going to be possible is by by being able to leverage not only a simple deployment, but by being able to deploy a simple model with a REST or gRPC API, being able to deploy an A/B test with multiple different models that can be actually tested against whether it's performance. You can have more sophisticated deployment strategies like multi-arm bandits or shadows or canaries. We can have things like these joint feature transformers that can be reusable across different pipelines. You can have other components like outlier detectors, and as we're going to cover later on in the point about ML insights, things like explanations. And we actually have a broad set of open source examples that you can try out that ultimately we encourage, but specifically in this context, we're going to be delving into the more holistic question of not just productionizing one model, but thousands of these models. And of course, when it comes to the deployment and containerization of a model, you have several principles in play. The first one is the auditability and provenance, making sure that your components are completely consistent, right? So you have your data that was used to train the model, the code specifically for the model, and then the input and output data that goes through the model once it's deployed. And this is quite important given that you want to introduce a level of reproducibility to your stack. Then you also have the requirements that don't go just on a single model, but across your entire complex data flow pipeline, right? So if you have multiple different models, you want to make sure that there's also the ability to reproduce the way that the data circulates across to ensure that you can replicate a specific data point that was processed for debugging or auditability perspectives. And then you have the metrics monitoring to ensure that you have the ability to monitor the models that you deploy. So whether it is for load testing to ensure that there are no outliers in the performance, but also, as we will see later on, for actual machine learning monitoring. And then, of course, the audit trails of everything that goes in and out of the model, making sure that you're able to understand and keep track of the relevant processed components, specifically, whether it is for audit purposes or if you want to then try to debug something that happened, at another point. But then there's the question also of how do you not only deploy a single model, but how do you ensure that you're able to continuously deploy multiple versions of heterogeneous models coming from a broad range of different model sources, right? So this is not just your specific Python artifact store, but it may also be your MLflow store, your Spark ML store, your RStudio models. How do you ensure that there is a continuous integration and continuous delivery? And for this, we introduce some core concepts that will be abstracted beyond the framework, but are going to be using this framework called Jenkins X. So Jenkins X is basically a project that was created from, as you may recall from the name, the Jenkins team. However, it has no relevance in its underlying code beyond just the name and the team, of course. However, this project leverages the cloud-native components of Kubernetes to provide serverless capabilities on continuous integration and continuous delivery. And this will become a little bit more intuitive as we go ahead. So the way that we would look at this perspective is going to be in two parts: the continuous integration and the continuous delivery. First, on the CI piece, let's assume that we have a data scientist, and we're going to see how it interacts with Jenkins. As soon as a new model is created, that will be able to go into the model implementation GitHub repository or version control system repository. Then once we want to deploy it, we would do this through the concept of GitOps. And GitOps is deployment as code through version control. So similar to how you have other things like infrastructure as code, deployment as code is basically keeping all of the deployment state in a version control system so that it reflects the current state of your cluster and you're able to revert back. So what that means is that whenever you submit a change, you're able to interact with Jenkins X, not directly by sending commands, but through the PR workflow, through what they refer to as chat ops, right? So this is basically through the PR comments, you're able to send commands to Jenkins X, which is in your Kubernetes cluster. And these commands are received by the Prow system. You can put comments such as /assign, which could be like a GitHub user. This could be like /retest or /test. Or if you actually want to approve a PR, you can put just /approve. And what you have is other commands like hold, lifecycle, or perhaps more useful commands like /joke that actually just posts a joke on the PR. And then similarly, the Jenkins X workers, what they would do is they would trigger the actions that are respective to the commands. And this would be using the serverless architecture, which in this case is using Tekton. It's the underlying framework that runs the CI steps. And in this case, you would have your build commands being carried out by the underlying scalable framework, which in this case, you can see the intuition is all using the traditional version control workflows, right? Submitting a PR, ensuring that people review it, and then the right individuals are able to approve or reject the PR. And then once you're able to, once you want to promote a specific deployment, you can do so similarly through the PR workflows. So here you can see the multiple different version control repositories that are into play. And here you can see some of the examples. Once you open a PR, you can actually interact with the Jenkins backend through the GitOps commands, right? /approve or /joke or /roof, all of these commands. And you can see that with this, we have been able to help as Seldon Core scales in its contribution. So Seldon Core is an open source framework. We have over 2 million installations. And as you can imagine, the contributions have also grown from our open source user base. Having this, cloud native capabilities has definitely helped us scale. And this is on the continuous integration piece, making sure that tests are run, that you have all of your PRs, being able to scale as the contributions come in. However, as I mentioned, a lot of this is led by the concept of GitOps. So this is basically ensuring that the actual deployment is all happening through a version control system. So once you go into continuous delivery, actually deploying data into production or deploying an application into production, this all happens through this version control GitOps workflows. And specifically into this, what you would see is that if you want to deploy a model, let's take this specific deployment structure. Let's say we have a production namespace with these models there, a staging namespace, and then in the specific Jenkins environment, that's where Jenkins is running. Once we actually create or train a new model, let's assume that we want to actually roll out a new version of our models. What we would do is, as soon as the model is ready, it would actually go through the continuous integration steps. And once we merge those changes, then the actual continuous delivery would be triggered. What would happen is the actual configuration as a Helm chart will be published, right? So this is what we're going to then be able to use for promotions across different environments. And then we can actually, leave everything else for Jenkins X to continue. So Jenkins X would actually open up a PR into the GitOps environment. As soon as the GitOps environment changes, then you can see that the actual models get updated. In this case, we've upgraded into version 1.1 and 3.1. And whenever we're ready to actually perform a promotion, this is also performed using GitOps. So automatically Jenkins X is able to open a PR which says, I want to promote these specific models into this environment. And once it's approved, then that's when the actual changes would be reflected into the environment. So the configuration would all be stored. And this allows you for more complex and sophisticated deployment strategies, like in this case, canaries or shadows. So here we have a percentage of the traffic being streamlined. And this allows you to actually deploy and scale your continuous delivery at broader sort of scales, primarily through these GitOps components, as then you're able to have the same standardized interface for the flows of each of the models that go through the different environments. And we actually have a hands-on implementation that you can check out. We encourage you to try it. And we also have not only the one with Jenkins X, but also the one with Jenkins. If you prefer to actually run it in a more sort of old school, well, I say old school, but that's what kind of happens today, as of today, right? And then the last thing is, well, so now we have a means to deploy models, but how do we now achieve the same perspective for other components, like things that allows us to explain models or to identify outliers of the models or to provide concept drift detection on the models? And specifically into this, we do need to be able to identify the ways in which this can be delivered, similar to how we're deploying and productionizing our models. And the way that we're able to do this is through this framework called Alibi. So Alibi is basically a set of state-of-the-art algorithms for explainability, outlier detection, adversarial detection, which in turn allow you to not only provide state-of-the-art tools themselves, but also be able to introduce processes that involve domain experts beyond technologists that would be in charge of performing assessments of data, assessment of model, an assessment of production model performance, right? And this is key, that it's not just about tools, but also about process and the humans throughout the different touch points. And what this allows you to do is to leverage what would be inference data assessment for class imbalances, protected feature assessment, correlations, model assessment for other things like model specific methods, abstraction of domain knowledge into features, feature importance, etc. On a global level and on a local level, i.e. per data point, what are the actual features that are more influencing the prediction of the model. And then also, of course, the production monitoring, right? Once you deploy a model, can you still perform explainability of data that goes through it? Can you deploy some outlier detection components? And the key thing here is, well, if we have thousands of models, we will require to introduce this advanced monitoring perspectives, but we need to abstract these capabilities into a means that allow us to really provide this at massive scale, right? And for this, not only from the explainability perspective, but also into the security perspective, there's the concept of adversarial robustness, security that models could be exploited on, such as by providing perturbations on the probabilistic inputs that could trick the models, right? So how do you actually abstract these core concepts into means that can actually scale in your infrastructure? And this is something that we have been able to introduce through a similar means to which Seldon Core provides you with the deployment of models. We also provide with the ability to abstract explanations or explainers into a similar means. So whilst your model provides predictions for every input data, an explainer, when you send a request, it provides explanations by reverse engineering the model. So this is basically an explainer pattern that, even though the underlying explainer inside of the model can be very specialized, this as an infrastructural component is something that we can still manage as an infrastructural pattern and as an IT component that then our DevOps infrastructure and those continuous integration workflows can still allow us to keep the full provenance across, right? And then similarly for outlier detectors and adversarial detectors, we can also abstract them into infrastructural patterns. And if you're familiar with cloud native approaches, this would be through actual custom resource definitions that provide you with that level of abstraction on these components that can be very highly specialized. And so with this, this is really important, given that what we have done so far is take very complex, specialized machine learning concepts like models, like explainers, like adversarial detectors, and then take traditional CI/CD and best practices of software workflow to be able to provide frameworks and workflows that scale to hundreds or thousands of models. And not only models, but also the components that surround those models themselves, such as explainers, adversarial detectors. And the reason why this is important is because this provides us with a ways to standardize and scale what are often highly complex machine learning concepts. And then similarly, providing full provenance on the model history through GitOps, right? So we can actually revert back these components, reproducibility through simplified rollouts, operational process with allocated touch points that go beyond the technical stakeholders, and then also governance and auditability to reduce the risks at scale, when you have deployments of hundreds or thousands of models. So this is important because this is also a challenge when it comes to just microservices, right? And this is why adopting these cloud native best practices and just bringing them into domain specific areas like machine learning is what allows us to really extrapolate these best practices that really allow us to scale as broader technical and broader teams. And if you're curious on what are other of the tools available, we actually curate a large list of production open source tools, which you can actually visit in this GitHub repo. And if there's any missing, please feel free to add to that. So also massive shout out to XKCD. If you notice, there's a lot of artwork, throughout the presentation. Their work is awesome. So, like always, check out and support their awesome work. And with that said, thanks everybody for your time. I hope you enjoyed this presentation on a practical guide, a practical CI/CD framework for machine learning at massive scale. So with that said, I'm more than happy to take questions. And if not, the examples are on the repositories outlined. So feel free to try them out or to add suggestions as GitHub issues. So yeah, thank you very much. And hope you enjoy the rest of the conference. Hello. Yeah, thank you guys. Thank you everybody for joining. I guess I assume this is working. But yeah, I'm more than happy to cover in a little bit more detail. I was currently answering some of the questions on the chat, providing some of the links. So in case you wanted to try out some of these things that we covered, they are in the documentation. And there's basically Jupyter notebooks that you can test both in Jenkins as well as Jenkins X. And of course, the approach that we took for this is, as with anything in software, one of the many ways to tackle it, right? So this is not going to be the ultimate correct solution. And that's why if you do try it and you have any suggestions, please do feel free to share them, whether it's on the Slack group. I shared the link for where you will find the Slack group, as well as opening an issue on the repo, which I also shared. So please feel free. So I think there's a question, and I think we have 5 minutes, so we could still cover a few questions. So it says, most of what you showed is for deploying models into production using GitOps. Do you also work on a CI/CD for training and improving models over time, i.e. Offline versus online? So that is a very good question. Specifically in regards to the answer, there are two parts to it. The first one is there an option without GitOps? And the second is there a possibility of adding the concept of offline, online retraining of models? So the answer for both is yes. And as you may already have assumed, the example with Jenkins Classic, not Jenkins X, doesn't use GitOps. Not because it can't use GitOps, because it definitely can. You just have to actually push to a repo and then sync it. But in this specific example, it just uses the traditional pipelines that pushes that. So now, in regards to the second part of, can you have CI/CD pipelines that also take into account the retraining of models? So this is actually quite an interesting point. The answer is yes. And we actually have seen a lot of production use cases where either automatic pipelines are created based on rules, or manual pipelines are created based on triggers that allow for the steps in the pipeline to actually run the training of models, right? When would you use automated pipelines? When you actually have semi-self-labeling data sets in production, which then you can actually retrieve, and assuming that you have a reasonable distribution of the data and you have your own policies to determine that, you'd be able to automatically retrain the models. Otherwise, when it comes to the offline, we have seen a lot of use cases where now there is sort of an ambiguity or a combination between the world of ETL, the extract, transform, load, and the world of CI/CD, where you tend to now do some of the steps in the ETL space, such as training a model, now in the CI pipeline. So the answer is yes. And I think that's something that we have also seen that has been quite interesting. And then another follow-up question is, can we get a link for the Jenkins classic example? So the answer is yes. So the link that I sent above actually contains both. So if you scroll down, you will be able to see the link to the CI/CD Jenkins Classic and the link to the CI/CD with Jenkins X. So more specifically, that's the link to Jenkins Classic, and this is the link to Jenkins X. But yeah, I mean, as you also know, the one with Jenkins X, it was created, a few months ago now, like maybe, 7-8 months ago. And as you may have seen how fast Jenkins X moves, if you do try it, there will be some changes that will need to happen. So we're probably going to have to update the example to use the latest Jenkins X. But at the same time, the principles and the workflows, which is the most important part, are still consistent, right? The ability to understand how a model would be able to not only transition into a specific environment, but also how you would be able to promote it into other namespaces, and more importantly, how you can actually use GitOps to do the promotions. And I think actually one thing that may be an interesting point to also mention, which at this point is more just rambling, but it's still interesting, is that one of the things that we have identified is that approaching continuous integration and delivery of models using GitOps also enables our environments to be extensible to things like multi-cluster strategies. And the reason why is because when you use GitOps, the way that you're able to deploy a model into the cluster, you would have to just push it into the version control repo, as opposed to modifying the cluster, right? So what that means is that if you have another cluster, the only thing that you need to do is to connect that repo to the other cluster. So then you can have very complex deployment strategies of models that you can then promote across completely different environments using GitOps. And I think that for us has been quite useful when engaging with very complex deployments that have to move from staging to production, involving actually different clusters, right? So that has been quite an interesting point that we've seen. But yeah, so happy to answer any other questions. And if not, also, I'm sure there's going to be tons of other sessions, tons of other exciting sessions to still cover. So yeah, maybe I'll give it a couple of minutes in case anyone else has further questions. And yeah, I mean, I can also answer them offline. So yeah, I'll give it a couple of minutes or at least some time. And yeah, and thank you again for everybody for joining. Yeah, I hope you enjoy it. The video is going to be online as well. Yeah, so yeah, I'll wait a couple of minutes to see if there's any questions, and if not, we can wrap up. Cool. I think Jennifer just mentioned next session starts in 5 minutes. So if you're planning to attend, yeah, make sure you click on the sessions for the next presentation. And yeah, I mean, I'm still open if anyone has questions on this. And Venugopal, yeah, thank you. And if you want to test more examples, you know, there's a broad range of Jupyter notebooks that you can try. But yeah, both in the Seldon side and in the Jenkins X side, I think there's always enough fun. Awesome. Well, I guess we can wrap it up there. And yeah, thank you again to everybody for joining. And I'll see you around in the conference.